Hi, today we are introducing Automated Checklist, a database administration tool that aims to make routine checks effortless. First, a little bit about ourselves. We are 3 backend developers from Digital China, and we all have varying amounts of experience working as database administrators for TiDB clusters. One common gripe of ours is that as powerful as TiDB is, performing routine database checks on it is not easy, and it becomes a tedious chore when you have to do it on a daily basis. We conclude few reasons. First of all, Prometheus plus Grafana is a comprehensive monitoring system, but as many powerful tools, they have steep learning curves and are far from easy to use. There are too many panels on Grafana, all of them showing symptoms rather than causes. Knowing which panels to look at requires prior knowledge about what the consequences of each error looks like. Moreover, sources of information are split between Grafana, Prometheus, TiDB dashboard, and databases. Doing one round of checklist requires retrieving information from different places. Lastly, it's hard to demonstrate the result of checked items. This usually results in countless copy-pasting or screenshots. You also have to consider how to present the result to the client, who might be non-technical. Therefore, when given the chances to make something at TiDB Hackathon 2021, we set out to build an automated checklist platform that is unified, configurable, extensible, and accessible. It should provide a unified platform to access information stored in Grafana, Prometheus, operating system, databases, or even logs. It should be freely configurable in terms of enabling or disabling particular checked items, changing check scripts, threshold, or even passing in additional arguments. Users should be able to extend the platform. They should be able to add in their own scripts, or even better, downloading scripts directly from another sources. Lastly, it should offer an intuitive user interface that can run all scripts with one click of a button, and should also be able to export the result to other compatible formats. Here's an overview of our platform architecture. It's split into many modules. Here, I'm just going to point out a few important ones. First, the run resources. This contains configs and each individual check scripts. This is the part where we opens up for the user for extensibility. There's also this run result, which stores the checked result in both inside a SQLite 3 file for front-end access, as well as CSV file for exporting. Another thing to know is that we build our website's web server using Go and Jin framework, but the actual execution logic are intentionally written in Python 2 and Shell. So it can be used on more mission-critical or guarded systems. Now, without further ado, let me show you how it works. You start by logging in with database credentials. Now, at the top are cluster metadata. Here are the recent checked items, and here are each individual checks. Those in red are the ones falls outside the acceptable range set up by the threshold. This is the warehouse. Here you can easily extend your existing check items by downloading scripts from remote sources. Here we download 2 new scripts that checks for a live TiFlash nodes number, and if any table doesn't have TiFlash replica. After downloading it, we have to configure it. Next, we added the config to enable these 2 new checked items. Notice how the VS Code is automatically pop out once you click the editing button. Next, let's execute a complete checklist. As you can see, it catches newly enabled TiFlash replica checks. You can see many tables doesn't have a TiFlash replica. Refresh the page, the metadata and recent list are updated accordingly. You can see the most recent result. Right there, we can see the new arrows. Finally, you can export the report as plain CSVs. Just click the export button and download it. Look how the Microsoft Excel recognizes the file format. So, what we have seen is the progress we made so far. We started by doing the installation, logging with database credentials, execute checklist with one click and have a real-time result feed. We built an intuitive UI with cluster metadata and past check result. We added ability to modify or add local scripts, modify configs or change threshold, and export result to CSVs. We also see how we can download script from remote sources easily. As for future plans, we intend to further improve our UI presentation, make it more easy to use. Provide a webhook for custom alerting system. Extend the remote script warehouses. Make it a fully fledged script store where users can share their own scripts. During the development, we also realized the potential of using the checklist result as a data sources for AI data analysis. So we proposed two ideas. First, we can feed existing data to a learning algorithm to produce a model that can discover and mitigate potential risks before they appear. We can also use it to run a root cause analysis to find out the cause of a problem after an error occurs and recommend solutions. Thank you for listening. If you find this interesting, you can find the project source code at the link on the screen.